Okay, welcome to part 3 of week 7 of cis204 Unix shell scripting and utilities, and we are continuing our discussion of interactive bash. And now I'm going to bring up something that's just more fun than barrels of monkeys, the directory stack. And to be honest with you, I've known about this for a long time, but I've not found any real good use for it. And I'm sure someone has, but I haven't figured it out yet. So what it is let's take a peek here. So I'm at my home. So if I cd to D and CI, that will take me to document cis204. Okay, cool. So what happens if I issue this command push D dot dot? Push the directory dot dot. Where am I? I'm now at documents. Okay. Pop, pardon me. Let's go back here and look. What's it saying? Push D dot dot again. Okay. So let's do that. Now where am I at? Well, it took me from document cis204 documents. Okay. Where am I now? That pushed the directory stack up one. So now I'm back to where I was. What happens if I pop D? Pop D? Yeah, pop D. Okay. Where am I at? Documents. If I pop to the directory again, the directory stack, where am I at? That takes me to home documents cis204. Okay. Wow. Meta characters, and we've talked about these on and off and on and off and on and off and on and off. They're basically characters that are used to represent something else. Shell meta characters are called wildcards, and we've seen that before in week 4. The escape, the /, interpret the following character literally. So if I use an escape in front of a dot, for instance, it looks for a dot as opposed to treating the dot as a wildcard. An ampersand will stick a process that you've just asked to perform into the background. A semicolon will separate the command. The $sign substitutes variables. Basically, the $sign in front of a variable name says, give me the contents of this variable. When I echo $path, and let me show you this. If I do this, so let's clear the screen. If I echo PATH, what do I see? I'm just going to see what I typed. It's going to echo what I typed, in this case path. If I echo $path, what will I see? I'll see the contents of the variable path. That's what I'll see. If I try to echo $city, city has not been set as a variable, it will tell me nothing. Echo city again, there I go. So that's what the $sign in front of a variable name does. It says, don't type the variable name, don't output the variable name, but output the contents of the variable. So a $sign will tell echo or another command to look at the contents of the variable. A question mark matches a single character, and a splat matches 0 or more characters. We talked about that in week 4. Placing a set of characters inside square brackets will match something in that character set, or if you put a ball bat in front of the character set, it will match the inverse, or a caret. Commands placed inside parentheses will execute in a subshell. Commands placed within curly braces will execute in the current shell. This is fun. Anyhow, here's a good one. Globbing, which is file name substitution. Meta characters can be used to abbreviate file names. So there are some examples in 13.9, starting on page 803, that we'll work through in class. But globbing is something that I've done for years and years and years. So Control L to get out of that. If I do this, using the splat, the dsplat slash ci splat, basically globs documents cis204. That's what that's doing. Okay. There are two types of variables available, and actually, yes, two types. Local variables are known only to the shell in which they're created. Okay, and environment variables. Those are available to any child process of the current shell. Variable names must begin with an alphabetic or underscore. And I'll be honest with you, I've seen the labbies used to use underscores and a capital letter for variable names inside shell scripts they were building on a regular basis. That seemed to be the way they dealt with variables. I personally, if it's a variable, it will be all caps. That's just the way I deal with it. Variable names have to begin with an alphabetic or underscore, and the remaining characters can be alphabetic, decimal digits, or underscores. So there's some examples on the page here: test 05, test underbar 05, underbar test 05, which are viable, useful, and can be created as variables. However, the examples shown below, 05 test, dollar test 05 or test.05, are not viable variables. Those can't be variables. The declare and typeset built-in. So two built-in commands to set variables. You can declare base variable equal value. You can also use typeset variable equal value. Now notice, we're talking about the bash shell here. So declare and typeset work within bash. They may or may not work within other shells. Your mileage may vary. So if I, without arguments, declare will just give me a list of variables. So let's see what we actually have. Remember, I had path. So let's pipe that to my alias for less, which is m. Broken pipe. So let's try this. Declare, right? Okay. Oh, look at this. I got all kinds of things floating around in here. These are all the functions and variables that were set. So I've got a set of subdirectories, this variable underbar sysvdr underbar terms, underbar tilde is a variable, underbar ufw is a variable, and notice it's got some if processing sitting around in here. If I keep going down here, I should end up seeing some of the variables that I may have set. These were all set using the, there's greet, which I'd set earlier, right? Okay. I've got an in underbar array. I've got a quote read line. So those are the variables that are set. So the declare command has options, and we'll go through those in class. The -a, the -f, the capital F, the -i, the -r, and the -x. Now, if you declare a variable, if I do this, let's clean this up. City equal Topeka. Okay, echo. How do I make this print the value of city? $city. Topeka. Okay. Let's create a new bash shell. This is bash running inside a bash right now. Echo $city. Oh, nothing there. Let's get out of this bash shell. Now, let's do this. Let's export city equal Topeka. Echo $city. Let's start this child bash shell and echo $city. That's what's going on. So by exporting city, I make that variable city available to every child process of the current process. So if I do a ps-ef grep for bash, you can see I've got two bashes running, a 20900 and a 25824. What's the parent process of 25824? Why, it's 20900. That's the second bash. That 25824 is the second bash I issued. It's a child of the 20900 process that I started with. When I exported the city equal to pika, that made that variable city available to the 25824 bash shell. Okay, let me exit that. If we do this, oh look, where'd my ps command go? Hey, come back here. Well, what happened is that ps-ef command was in the history of the 25824 bash shell, which I just exited from. So that's something to bear in mind too. So we'll take a look at this again in class. There's a panoply of environment variables that are assigned at the shell startup. You saw some of those when I did the declare. Refer to table 13.14 on page 814 of Unix shell scripting by examples. And the setting environment variables requires you to use the export command if you want them to be available outside of the current shell in child processes. There are a number of options you can use, the -f, the -n, the -p, and then we'll look at an example on 13.55 to see how an environment variable is carried over to spawn shells, and you just saw that. So we'll do that in class. Unsetting variables. So if I set that city, echo $city, right? $city to pika, unset city. Okay, echo $city. Hey, that's a good way to get rid of that. So if you want to reuse a variable inside your shell, if you want to declare a variable just var, and you're building a shell script and you want to use var all the time, set and unset it. Heck of a deal. Printing the value of variables. So the echo command is a built-in, right? The options referenced in Unix shell by example text are not POSIX compliant, and you can't use them in the image we are using. The printf command is the preference if escape sequences are required, and we'll look at that printf command examples sitting on 13.59, 2 through 6. So we'll look at that in class. Variable expansion modifiers. You can allow a variable to be tested or modified, and we'll take a look at these. We'll also, since this is the third hour, we'll take a look at some of these as we go. How about positional parameters? Well, this is kind of an interesting thing. I can set some parameters. Let's do this. Let me do this. Set Tom, Dick, and Harry, okay? Echo $1, $2, $3. I set Tom, Dick, and Harry. Echo $2, $3, $1. It should be Dick, Harry, and Tom. That's special. It worked. Okay. So the built-in variable is used by the shell to pass arguments from the command line or used to hold the value of arguments passed to a function. They're positional parameters since they're referenced by the number of their position. So you set a series of things separated by white space, and then you can echo them based on their position. So Tom, Dick, and Harry. If I want Dick, Harry, and Tom, it will be $2, $3, $1. Okay. Other special variables. Now we're getting into the fun stuff. So these are special variables that consist of a single character. They can be examined using the echo command. So I'm going to do an echo. Let's clear this out. Echo $. 20900. Where have we seen that before? Well, would you believe that is the process ID of our current shell. Echo $. Okay. Echo. These options are set for this shell, $dash. Let's echo $dash for grins. HIMBH. Okay. Then, if I do a more Etsy group, and echo $? We all know what this is. This gives me the exit code actually, of the last command. It completed successfully. So if I sleep 25 and put that in the background and echo $ballbat and $ballbat, it will tell me the PID of the background job. Okay. Well, that's special. Quoting. This is something that's been asked before. Quoting is used to protect special meta characters from interpretation and also to prevent parameter expansion. So I can protect the meta characters, I can keep parameters from being expanded. Single quotes protect all meta characters from interpretation. Double quotes allow variable and command substitution and protect any other special meta characters from being interpreted. Single and double quotes have to be matched. If you put single quotes on one side, there better be a single quote on the other side. If there's double quotes, there better be double quotes. So, let's see. Echo, let's actually clear the screen. Echo // So, okay. It echoed the slash, the forward slash. What we see with this job is the fact that this command echo / the escape basically happened after this job sleep 25 had ended. So let's do this. Echo // There you are. Okay, that worked pretty good. Now, let's put it inside single quotes. What should happen here? Anybody guess? I get 2 slashes. Don't interpret the meta character. Leave it alone. Okay, now I'm going to do this because I've got these craptacular Microsoft double quotes around this thing. Control V, up. Paste that in there, and we'll do that. So what's going to happen here? I'm going to hi Hugo, the time is, and then it gave me the date. Cool. Okay. What happens if I do this? Okay. Echo, do this. Paste that into there. So, the time is 13:40. Cool. Okay, that worked. That's neat. Now we're getting into some useful stuff here. So, arithmetic expansion. The shell evaluates arithmetic expressions and substitutes the results. The expression is treated as if it were in double quotes, and the expressions may be nested. So you can see how this works. So we'll actually do this in class. One-dimensional, not the British pop boys group One Dimension, arrays can be declared using the -A option. And yes, I know it's One Direction, but I've got a granddaughter who thinks One Direction is wonderful, and I keep telling her it's one dimension. And that makes her mother chuckle, and she gets mad at me, which is my job as a grandfather. So we've got an example on 1379 that we're going to look at, and here is an example, which is this declare -A friends. Friends equals Shirley, Peter, and Lewis, and now I want to echo the contents of friends. Actually, I want to echo the first member of that array, which is Shirley. So there's this wonderful little geek stuff thing that I can put into the regular slides that you'll have available for you. And there's also an example that we're going to look at, and We'll go from there. Functions are used to execute a group of commands within the context of the current shell. In other words, they'll work within the current shell. It doesn't fork a child. So they're like scripts, but they're more efficient. They become memory resident in the shell. They take up space in your shell's memory. It can be used to improve the modularity of the script, and it's generally defined in the initialization shell or defined in that .bash profile. That greet command that I had built is a function. So here's defining functions. 2 ways of declaring function: underbar name. Man, that looks just like C. There's another way: function name, curly braces. So here's a function: function greet, echo, Morgan, log name, assist, and then the hour and UR. So that works, and we'll play with that. Again, standard I/O and redirection. This standard in, standard out, standard error. The old familiar operators are in force here. One that overwrites the no clobber, well, this is greater than pipe. That will actually, if the no clobber is set, that will ensure that that file gets overwritten. There's always another way to do something. The exec command replaces the current program with a new one. It doesn't spawn a new process. It just replaces the current one with a new one. And we'll play with this in class. Pipes. We've all used pipes by now. A pipe will move output from one command and present it for input into the other. In essence, the standard out from the first command becomes standard in for the command to the immediate right of the pipe. You've seen it already. You've used it in projects. There's a special redirection case termed a here document that utilizes a key to stop processing of text, but we're not going to go there for right now. Also, we're going to take a peek at, in class, shell options and built-ins, and that's because these things are very handy if you're setting up a specific environment to help do programming. But that's all we have for the online lecture for week 7. We'll go over a lot of this again in class, but by now, with week 6 and week 7, you should have a pretty good idea of how the interactive piece of the bash shell works, and since this is the environment you're going to be living in. So thank you for putting up with us, and we'll talk to you soon.